And we are there. All right, folks, give me 1 second here. You should be seeing my slide deck that shows the 51 Enterprise Workshop title slide. What I'm going to do is I'm going to give just a little bit of background of what to expect over the next 90 or so odd minutes, and then we'll get started pretty quickly here. So just a quick note, let me verify. Yes, this session is being recorded. You will get a link to all resources at the end. So when you registered, we captured your email so we can send you follow-up materials. As I mentioned earlier, use that Q&A widget in Zoom to ask any questions. I have it open off to the side. I'll keep an eye on it as questions come through. This is not like an official like certification type course, so there isn't like a certificate that goes with attending this. This is meant for your own education and edification, and again, to learn more about 51 Enterprise. And this presentation is going to be a combo of concepts and demos. I'm going to make it as interactive as I possibly can. That's generally how you learn the most, is being able to see things in action. If you've used 51 before, you will see a very similar user interface than you've probably been exposed to. I'll show you kind of the subtle differences that are part of the enterprise platform from an architecture standpoint and a usage standpoint, as well as, of course, a feature standpoint. But again, there'll be, some slides that I'm using to signpost and illustrate some concepts. But again, the goal here is to really kind of show you like what are the main features and like, workflow aspects of 51 Enterprise. So are you in the right place? So you are definitely in the right place if you have taken any of our previous or any of our what we might call prerequisite workshops, getting started with 51 and advanced data curation. Again, it's not an absolute requirement. Those workshops are focused on the open source platform. Again, it's just helpful if you've taken them. I will do kind of a high-level flyover of 51 here at the beginning. So if you are new to 51, again, you'll get that exposure. This workshop is about using 51 enterprise features and workflows. So just as a little bit of context, 51 enterprise we can think of as a superset of open source 51. It includes backward compatibility with all the open source features, but it includes add-ons that are generally meant for what we might call enterprise scale. So we're talking about teams that are collaborating on data sets and model review. Enterprise controls that you would expect, like dataset versioning and integration with like massive, data repositories. From an architecture standpoint, 51 Enterprise is a client server model rather than something you just install on your local computer. So things like that. This workshop is not an in-depth like computer vision 101, computer vision theory, intro to Python programming, or introduction to 51 basics. Once again, I will very much go through some of the flyover, like high-level details of 51, but it is not meant to be a total crash course to becoming an expert in 51 open source. That's not really the purpose of this workshop. So just as a little bit more context here, this is a slide that is actually we show in our Getting Started to 51 open source workshop. All of these same things apply. So if data seems to be the bottleneck, preventing your models from getting into production, if you see this statement, data eats models for lunch, and you're vigorously nodding your head, if you just aren't, or if you're just struggling to gain insight into your data, that is, you have access to your data, but you're struggling to kind of visualize things like embeddings, know what your data distribution is, know your class balance. That's what this is for. And then ultimately, the North Star is you want to learn how to train better models by curating better data sets. Again, all that applies here. And then I'll add specifically for 51 Enterprise, you work on a team that wants to standardize and scale machine learning workflows. So once you're realizing, hey, it would be nice if we're not all forced to install 51 on our own laptops, if we can have a better model to collaborate on our work, that is largely what this is for. So here's our agenda. Again, I'm going to try to dive pretty quickly into like the meaty stuff, the technical concepts here. I'm going to give a brief 51 overview. Again, just kind of a flyover of the key components just to get us all on the same page. And then we're going to talk about what we might call enterprise workflows. So again, the goal isn't just to be like, here's a feature, there's a feature within the FiftyOne enterprise platform. Rather, it's to show like what actual workflows are we doing here, and then where would we be in FiftyOne enterprise in order to accomplish them. So that'll include dataset management at scale. So FiftyOne open source, you're generally working with data locally unless you're connected to some kind of mounted file system that abstracts over a larger data repository. That's not the case in FiftyOne enterprise. Data lives in some generally cloud-backed repository or warehouse of some kind. You'll also be familiar that if you've used open source FiftyOne, you're probably used to the fact that so much interaction with the platform happens with the SDK. So you're running Python commands, classes, methods, scripts in order to generate the different views and workflows that you see in the app user interface. That is still possible within FiftyOne Enterprise, but we'll also notice that a lot more what we call out-of-the-box workflows are baked into the UI. A lot of the operations that you would perform are more UI-centered, with still the option to use the SDK. Collaboration. So FiftyOne open source is single user, single machine, generally, unless you kind of come up with hacks to work around that. FiftyOne Enterprise is multi-user. So as soon as you log in for the first time, you will notice that you're in a more user login data set browsable view rather than you're on your local machine and then running commands in your terminal to launch individual data sets and views. This multi-user, multi-data set browsability takes place in the UI, or can take place in the UI. Next, then we'll talk about safety and security. That's not just meant to be like check boxes that your platform and security teams need to check. We'll talk about things like dataset versioning. That is, how do we adopt a Git style workflow with our datasets, just like engineers are used to for source code, so we can have a lineage aware history of the work that we've done. And then finally, we'll talk about some next steps. All right. Once again, just as a quick reminder, as we go through, I highly encourage you, as questions come up, to use the Q&A panel in Zoom. Again, you might need to open up that three-dot context menu where it says more in the taskbar. Again, I'll pause kind of strategically for questions as well as they come up. And again, I have my colleague Kirti on the call with me. She'll be keeping an eye on the Q&A also for most of this call. Right before we dive in, just quick, who am I? My name is Nick Lotz. I work for Voxel 51. My title is Technical Marketing Engineer. So just the high levels, my goal is to take technical concepts and make them understandable for users of 51. My academic background is actually more in chemical engineering, specifically systems engineering. That's my academic background. And then, I moved into software shortly after school. The way I describe it is it's all numbers. Instead of chemicals instead of masses of chemicals flowing in and out of pipes, it's instead bits moving across a network. It's ultimately all math. I am based in the southeastern USA in the Nashville, Tennessee area. I've previously worked at companies like GitLab and Harness. Those are more kind of DevOps, AI native DevOps specific tools. Now moving into Voxel 51, more with a computer vision focus. All right. Just real quick, just to add a little bit of like humanness to the person, hopefully presenting here. What I like to do is when I'm not staring at a computer, I like to go on top of mountains and take pictures. It's sort of, for me, the ultimate like antagonist to having to sit at a computer all day. Picture on the left side is what's called Dragontail Peak, specifically Kolchak Lake in the North Cascades in Washington State. Middle picture is on top of Mount Rainier in the Seattle area, also in Washington State in the USA. And then picture on the right is Zion National Park in Utah, on top of a perch called Angel's Landing. Highly recommend any of those hikes if you are that sort of person. Okay, let's quickly move into Voxel 51, and then very quickly, I'm going to start moving into the actual technical deep dives. So real quick, so 51 is the open source project. it is stewarded and maintained by the company Voxel 51 that I work for and that Kirti works for. Voxel 51 also develops and produces the 51 enterprise platform. So it's that typical open source enterprise distribution model where we have that core open source offering. It's Apache licensed. It's maintained by us, but ultimately contributed to by the community. And then we have the open source, we have the enterprise version that we can think of as a superset of the open source distribution. It includes everything in open source plus enterprise features. Where does the term voxel come from? Well, a voxel is to a video, like a pixel is to an image. It's literally a volume element in the space-time volume of a video. The history of Voxel 51 is we did a lot of video analysis early in our company history. Now, as we'll see, we're multimodal. So we support images, video, 3D point clouds, grouped data sets where multiple modalities are represented together in individual samples. All right. Yeah, you'll have to check me on the audio one, Michael. I haven't worked a whole lot with audio myself. Yeah, I don't know what the bits of audio are called actually. I've worked only with mostly visual media and then text-based. Good question. If anyone wants to throw the answer in the Q&A as well, if they look it up, that would be great. All right. Okay, real quick, 51 overview. I'm going to make this quick. Again, I want to get into the kind of core content here fairly quickly, but just as a flyover. Ultimately, you can think of 51 as it's a Python library that is for curating and managing data sets that are used to build computer vision models. It is not just data set analysis. There's also model training, evaluation, and analysis side by side. There are quite a bit of integrated workflows involved with the data set. So for example, we hook into and integrate with annotation platforms that allow you to optimize data set labeling. So it is really meant to be at the center of your end-to-end computer vision workflows. And it kind of comes with like the thesis that you can't out-train bad data. So there was, in the history of machine learning, right, going back to the expert systems of the 60s and 70s, there was an original sense that, okay, the success of machine learning models are based on perfecting the algorithms that they are made out of. So tweaking these algorithms and the math around the algorithms and the architecture of the models themselves is how we improve model performance. That has hit a wall over the past couple decades, where ultimately, if your training data is poor, garbage in, garbage out, right? So ultimately, the model itself reaches a limit when you can't out-train bad data. There's a similar term we hear when it comes to like health and fitness, right? That you can't outrun a bad diet. You can exercise and exercise and exercise all you want, but ultimately, if the fuel going in is low quality, your overall health can only be so good. Same thing with computer vision models, or really AI models of any kind. And the reason for this is because the recipe of machine learning models are largely based on that data. So for example, if the data itself is poorly distributed, then you can have model bias issues. So for example, there was some cases, there's actually an MIT gender study from several years ago that showed that a lot of Google's machine learning models did just a really bad job correctly identifying ethnicity and making the right associations with it. And that's because certain ethnicities were very poorly represented in the data. There just wasn't good class balance in the data set. If edge cases aren't represented correctly in the data, that can have like lethal consequences, right? So think about self-driving cars. If rare events that are still possible aren't accounted for in the training data, then the model naturally won't be able to identify or react to those events. So for example, there was a Tesla autopilot crash with a parked vehicle at night. Who knows what like the contrast and glare was? That data wasn't properly represented within the training and validation sets. And overall, the result is just a reduction in model performance. So we'll look at like key model evaluation metrics here in a little bit. Just those core metrics, precision, recall, F1 score, accuracy, those those go down if the data quality isn't good. And there's not a lot you can do on the model architecture side that will like explode those numbers up in the right direction, absent improvements to the data set. So where 51 fits is really in this data set curation and optimization layer. So one way we can think of 51 is it's kind of like the hub in a broader hub and spoke mechanism, right? You have your data, and then you have the analysis and curation of that data. And then that ultimately feeds into the training and deployment of models. 51, this is actually I like the next slide better. 51 is at the center of all of this. So the idea is at any point in your computer vision workflow, you have easy access to the data that such that any optimizations you make can immediately be directed back into data sets and data set improvements. A key view we'll see in the UI here is being able to see your data side by side with any other work that you're doing in your computer vision workflow. So for example, if you're identifying, false negatives with result to a specific class in your data set, you'll want to be able to identify those samples side by side, or the affected samples side by side that might need maybe improved annotation, or maybe they're poorly represented, so you need more examples of that class to like better train your model, things like that. So this is the one I like better. This is more that hub and spoke view. Ultimately, again, the idea is 51 we'll see is a very extensible platform that is, it has an open plugin framework. Anything that's not native to the platform, you can integrate with basically anything you want. We have what's called an operator model that I'll talk about a little bit later. So regardless of where your data lives, 51 can import and make use of it. Wherever you're doing your annotation, 51 can hook into it. Model training and evaluation, there are native methods and classes that you can run within 51, or you can arbitrarily add like model predictions to your 51 data sets as well. From a compute standpoint, so any compute heavy tasks, such as computing vector embeddings, for example. Again, a lot of this is native to the 51 platform, but we also have what's called we have a plugin framework, and we have operators, and we have what's called built-in compute that allows you to delegate compute tasks to associated compute clusters that can be also monitored and run within 51. Okay, one last couple notes here. When I use the term 51, I want to be like very specific in what we're talking about. So again, I'm still talking about 51 generally, so everything I'm saying right now applies to the open source version of it. When you pip install 51, you are pip installing the 51 library. So that is the core library that includes the SDK. It also includes the built-in web service that allows you to launch that app UI that you can run in your web browser on your computer. An associated dependency that can be imported and used is 51 Brain, which is a set of machine learning methods that can be run like with and as part of the 51 library for things like computing embeddings, computing metrics like sample uniqueness and similarity distributions, and mistakeness. That is like, what is the likeliness that there are label mistakes in your samples, or prediction mistakes in your samples. So 51 Brain is a compute mechanism that is developed separately from 51, but is used as part of the 51 library. So just long story short, when I use the term 51, I'm really talking about this core engine here. There are features that you'll see that are part of the 51 Brain library and module that's generally pulled in as a dependency. And when I use the term capital A app, that refers to like the browser UI, that when you're using the open source version, that means you're generally running 51 commands, the library, and then you're rendering dataset views and results within the app in your browser. Again, these are still fundamentally part of the enterprise distribution as well. We'll just be doing a lot more work inside the 51 app. And this is what I mean by the 51 app. So this is an okay screenshot. I'll show you a couple others here in a moment. Ultimately, it's the GUI. So if you're running 51 open source, you start off by opening up a Python terminal, import 51, and then you might import a data set, and then you'll run a command like session equals fo.launch_app. That opens up this web service in your web browser that's just running on localhost. If you're running it on your computer, that allows you to render these dataset views. If you're running open source, again, it'll be app first most of the time within the enterprise version. And the reason for this is because ultimately the idea here is we have a much better view, a much more intuitive way of viewing samples versus just like browsing around your local file system or your S3 bucket, right? Because what this GIF is showing is not uncommon among like computer engineers and computer vision engineers, right? You're ultimately just going through your individual data and hoping that you're identifying the right samples that are being affected, uh, that are affecting your model. In FiftyOne, on the other hand, the idea is you have this grid that shows everything sample first. You can slice and dice, you can filter into specific views. I'll show that here in a minute. You can compute embeddings and lasso a section of the embeddings distribution and then see the grid reflect, those edge cases that you might be looking for, and much more. Okay, so enough of that. Let's talk about FiftyOne Enterprise. So it includes everything that I've talked about so far, but features included that you would expect to see on a larger team that's working on computer vision tools. So the reason for that is the FiftyOne open source library, because it's open source, well, not because it's open source, but as it's built, is ultimately single user, single machine. It does not have a user database. It does not have role-based access control. You're launching data sets ad hoc, so there isn't like a browsable way in the app to persistently open data sets. They live in folders on your local machine unless you have like a mount point in your file on your local file system that's from somewhere else. And then a lot of the out-of-the-box workflows that are SDK only in the open source version are more native within the app in FiftyOne Enterprise. And there's a lot of like cloud integration tools as well that we'll see here in a minute. So what I want to do now is I'm going to start stepping through these. Basically, if you're thinking about when I'm going through computer vision workflows, like what are the different steps that I'm performing? And then if I'm in like a larger organization, if I'm not in a greenfield enterprise, if I'm working with existing data, if I'm trying to improve on existing models, how can we start to represent these steps within the FiftyOne Enterprise platform? Okay, real quick, depending on your background, this is a slide that like might be very useful for you. It also might not, and that's okay, but I find it helpful to like, before I learn about the user-facing features of something, to know what is the thing made out of. So as I said before, FiftyOne open source is just a Python library that you install on your local computer. It actually also includes MongoDB as a dependency that'll almost always run locally. It doesn't have to, but most of the time you're running a local instance of MongoDB for storing like metadata and labels. And the data sets themselves live in like local folders on your computer. FiftyOne Enterprise is a client server model. So it is deployed using either Kubernetes or Docker Compose. So it's deployed in a series of containers. And they'll be represented as pods in Kubernetes. The database itself won't be containerized. It'll be some kind of MongoDB that is running somewhere, whether it is a directly like maintained persistent MongoDB or like a MongoDB as a service. Ultimately, the app pods and the FiftyOne library and the SDK and the API, those are running as Kubernetes services, and then they are accessible in a web portal. So your company will set up DNS such that the primary Teams pods are being routed to as a domain that you can access. And what you'll notice is that unlike the FiftyOne open source library, when you access FiftyOne Teams, there'll be login integration with your company's SSO. So again, if you're using FiftyOne open source, you're just there isn't like authentication in the same way, right? You're just launching the app because you're logged into your local computer. With FiftyOne Enterprise, they'll be integrated single sign-on. So it'll hook into your company's identity provider. And there'll also be API authentication. So I'll show you in just a little bit that you can create your API key such that if you're using the SDK on your local computer, you can authenticate with to your FiftyOne Enterprise instance using the SDK. Um, it's worth noting that, again, so much can be done within the app UI, but at the same time, we still have backward compatibility with the Python library. And that's where that API authentication comes in. If you're writing scripts, if you're performing ad hoc Python commands, you can still do that. The other really important aspect has to do with data, has to do with where your data lives. So in FiftyOne open source, the data lives in local files and folders on your computer most of the time. Again, unless you have a setup where you have like an iSCSI server and then you're mounting it onto your local machine as a mounted file system. But either way, it's still using file system protocols. That's in an enterprise, in a large organization where you have gazillions of data samples, that doesn't make much sense, right? Is every user going to have like a local copy of the data on their machine? Even if you have it mounted, you have to deal with like file locking and read-write problems. So the way FiftyOne Enterprise works, is that it hooks into wherever your data lives in the cloud. So at the simplest, that could mean a cloud bucket, whether it's S3, Azure, Google Cloud, any S3 compatible protocol object store is supported. So the source of truth, where the data lives, is in that cloud object store. And then when you're actually working with the data on your local computer, there'll be like caching that the FiftyOne app does locally to ensure, a certain level of performance. Additionally to that, so much data these days lives in a kind of an additional abstraction layer in like a Snowflake or BigQuery or Databricks data warehouse. We have integration to that as well through a feature that I'll show called Data Lens, which means that rather than having to import or represent an entire data lake as a data set, which is not practical, you can have ad hoc integration with a data lake such that, let's say you have a data set of 100,000 samples, but your data lake is much bigger. You can query that data lake to import new samples that improve your data distribution in the data set you're actually using to train your models. And we'll show how that works here in a little bit. So you have your big data lake, and then you can integrate with that data lake and do one-off queries such that, if you realize that, hey, there's certain samples that aren't represented well in your data, you can pull those types of samples in. And that uses what's called FiftyOne's operator framework. All right, so let's start talking through this. We will start with the idea of cloud-backed data sets. So again, where data ultimately lives, and I'll flip over here in just a second, is not on your local computer when we're talking about FiftyOne Enterprise. It is your local computer with FiftyOne open source. You go to there's normally a FiftyOne directory made on your local system that includes the data sets and their raw image files or whatever visual media files are there. In FiftyOne Enterprise, it uses what's called cloud-backed media or data lens. And I'll flip to that here in just a second. But ultimately, cloud-backed media, when you see that term in the documentation, it means we're talking about a cloud object store. With data lens, that means it is a data lake, a queryable data lake, right? That has a more abstract schema than just an object store. And the difference being is that the object store refers to the source of truth for the data set files. With data lens, the data lake is an optional resource to pull additional files into your data set. So the data lake integration means I want to query my data lake using FiftyOne as the interface. And then if needed, pull these samples, import them back into my data set to better improve my class distribution or the size of the data set or whatever distribution I'm looking for. So here's what I'm going to do. I'm going to start fresh here. I am going to actually just sign out here just to kind of show you what it looks like fresh. Okay, so real quick, if you have used the FiftyOne open source distribution, you are used to opening a terminal, running Python commands, and running commands that ultimately launch the app. In FiftyOne Enterprise, you will navigate in your web browser normally to FiftyOne as a user. Again, you can also perform API authentication using the Python library as well, but if you're just directly working within the app, it is persistent. So here we have this demo system that is reachable at demo.51.ai. I'll talk about this later, but if you're interested, we have a read-only kind of trial environment that we call try.51. Whoops. that if we go to try.51 here, I'm already logged in, but you can sign up. Let's see if it'll let me. Yeah, you can sign up with either LinkedIn, GitHub, or Google, and that'll drop you into an environment with some tutorials that'll allow you to get exposed to the product if you haven't seen it yet. It is read-only, so you won't be able to perform everything that I'm doing here, but you will at least be able to experience the interface similar to what I'm showing. I'm on this demo system. Notice the single sign-on here. It'll integrate with whatever SAML, SCIM, IDP provider you have. And when I log in, the first thing I'll see is a dataset view like this. So all of these datasets are ultimately cloud-backed. They have a cloud object store backing them. So again, different from open source, right, in which you're launching ad hoc dataset views. I am going to open up a dataset that is a version of the Berkeley Deep Drive dataset. So lots of automotive self-driving car images. Mine's a very small subset of it here. So we see it's 650 samples. Ultimately, these samples live in the cloud. That is their source of truth. And I can see this in a couple different ways. The first way is if I click into any of these samples and it opens up here. So here's kind of a blurry looking sample. If I go to the primitive section, I can see that the file path, we can see the clue here. This is ultimately a path in a Google Cloud storage bucket. So the bucket is called voxel 51 test, and then the ultimate like blob path is BDD 100K validation, and then this cuts off, but this is just a UUID representing the JPEG file, and then all the other samples are similarly in this path. If I wanted to import more samples, there is a function, an operator function here called import samples. This, again, only exists in FiftyOne Enterprise because cloud-backed media only exists in FiftyOne Enterprise. And I can choose what I want to import, media, label metadata, or both. We have a variety of supported dataset formats. So when you are creating datasets in FiftyOne, if you've ever done that using the SDK, you find in the documentation and in the SDK documentation a list of like the different supported dataset formats. That's repeated here. So it includes Cocoa, Kitty, which is often used for multimodal, YOLO, and then we have FiftyOne has its own dataset format as well. The dataset directory is where in the cloud does this live. So I can check the different cloud providers. Quick hint, we support more than just Azure, AWS, and Google. Ultimately, we support any S3 compatible object store. So a little bit of a hack around it is if you click AWS ultimately and you have cloud connectivity to an AWS or to any S3 compatible object store, even if it's like a private object store like MinIO or something, you can do that here. So for example, here's S3. Here are the S3 buckets we have, and I can drill into one of these if I want to and import any data from there. Now, how exactly do we connect to an object store? Well, if I go to the settings aspect and I go to cloud storage, here are my cloud storage credentials. So again, this is part of the broader management of FiftyOne Enterprise, where if an admin, which I am on this demo environment, can add a credential to a particular bucket. So right, it could be access keys, it could be in an init file, and that will allow FiftyOne to recognize those and then render the buckets through using those credentials. Okay. So the source of truth here are cloud buckets, both media and labels. Now, as I mentioned before, I have 650 samples. This is a very small data set. I likely have a large repository, a data lake of raw images that I might want to connect to. Now, they're not part of the data set, but in my organization, I might have say, a Databricks data lake of millions, if not billions, of data that's been streamed, potentially by, if I'm in a large organization that's doing this, by like self-driving cars we have on the road, right? That's constantly gathering sensor data and streaming it, maybe after some minimal processing, to our data lake. That uses a feature called Data Lens in terms of how FiftyOne interacts with it. So if I go here to this panel view, so let's say I want to improve the class balance in my data set. If I go to this panel view and I can go to a feature called Data Lens, and I'll put it actually side by side with my samples here. This uses a feature called FiftyOne operators to connect to your data lake. So this is a very flexible model. So this interface here is ultimately what this looks like is likely going to be different for each organization that implements this, because their supported ways in which they query their data lake is going to be different. So what you see here is not like the out of the box, anyone that installs FiftyOne is going to see this view. This is determined by what's called a FiftyOne operator. So before I query this, just real quick, just to kind of understand this, if I go back into settings here and I go to plugins, we see a whole list of plugins. I'm not going to go into too deep of like the FiftyOne plugin framework. If you Google FiftyOne plugin framework, it'll show you how like the plugin framework works, how you create YAML files that represent plugins and how they point to source files that determine how the plugins behave. Built on top of the plugin framework is a concept called an operator. An operator simply means some kind of program built on top of the plugin framework that extends FiftyOne's functionality in some arbitrary way. That is, basically you're building on top of the FiftyOne library or the FiftyOne user interface to include some kind of additional support and capabilities. So I believe here, if I search for Databricks, yes, there's this Data Lens Databricks operator that is hooking into FiftyOne, basically the plugin code, which I'll show here in a moment, or the operator code, like it's import FiftyOne SDK, and then import the Databricks SDK, and then the Python code for the operator is interacting with both in order to build in the support for connecting to Databricks using FiftyOne. So what that looks like, just real quick, is I'm going to switch my screen over here to VS Code. This is an example of like of what we call a Databricks connector, which is ultimately an operator which is uploaded to your FiftyOne installation as a plugin. So if we look at the top here, again, we see all these import statements that include both Databricks libraries and FiftyOne libraries. We have this class called Databricks connector, and this class includes like several methods around how are we querying Databricks. So for example, we have all these query parameters we're defining that allows us to like query based off classifiers like time of day and dusk or dawn, and is it clear or rainy weather. And then we have a method for actually like handling the request to Databricks. And then we have a new class called the Databricks handler class that is initiating the client and then iterating through the results fetched from Databricks, and then finally transforming the results into samples that FiftyOne understands that are in the FiftyOne like data format, rendering things like bounding boxes and other metadata on the samples, and then like returning them to the FiftyOne user interface. And you can actually find this on our documentation. This is an example. If you look up the Data Lens documentation, you'll find this as like an example. You'll find one for Databricks and one for Google BigQuery as well, to just kind of see the structure of how these operators work. Let me go back here. Okay, so that's just kind of giving you a sense of what that means. So going back to Data Lens here, again, this is determined by like the supported operators we have. So for example, some of these are like demos, but like Databricks is the main one we support here, just based off what we've uploaded onto this installation. So if I go to query data, this is allowing me to query my Databricks data, and then for certain parameters, and then only if I like want, only if they like match what I want, then I can choose to like import into my data set based on that query. So right here, we can see the query parameters are actually a bit different from the operator I showed a moment ago. So the operator I showed earlier, I was quick, but it was like directly checkable boxes, like you're checking the time of day and things like that. This one's a little more interesting. This is actually leveraging Databricks vector search. So I can search using natural language, and it's leveraging Databricks' vector search embeddings and then returning the results that match that natural language query. So for example, if I search for pedestrians walking, or maybe pedestrians in crosswalk at night, right? This is something where I'm like concerned my model isn't performing as well as it should. So maybe I want to import these types of samples into my data set. And in a moment, I should see returned samples that match that query. Now, I'll see them in a preview pane here. They won't be part of my data set yet. I'll have a chance to import them in a second. And here they are. So we see, again, some of these might be a little bit hard to see depending on the zoom, but we can see that, for example, here we have clearly pedestrians in a crosswalk at night. We see some examples here and here. We see the bounding boxes. Right now, checking these, like this checkbox doesn't do anything quite yet. But what I can do is, given this result, again, this is just the preview, so this is just showing a representative preview. If I actually want to import samples, I can click this import button, and then I can select out of the entire distribution of this query in my data lake. Again, it might be more, it'll probably be more than just whatever I've previewed here. Do I want to import a select number of samples, or like all the samples that matched my query? If they already exist in my data set, I can skip them, and I can import them into an existing data set or a new data set. I can optionally tag them. So I might say I'm going to just use small numbers here just for brevity's sake. So I'll say like 20 samples that match this query, because again, I have a small data set. And then when I actually do the import, I can choose to either run this task directly in the foreground, which means that it's going to take up my screen and it's going to run the compute directly. What I can also do is I can schedule this task as a delegated operation. So another feature of FiftyOne Enterprise is that you'll hook your installation into some kind of compute that allows for background tasks to run. So when that runs, that'll be available here in the runs section as a background task. I'll go there in a moment. For now, just for the sake of running this quickly, I'll run this in the foreground. And notice my current view is 650 samples. This will change to 670 here in a moment as I import the new data. Now, I'll let this is running in the foreground here. Looks like it finished. If I view the new samples, notice we now see it's been updated to 670. Now, what I didn't do here, which I could have done, is I could have added tags to like directly indicate what are the new samples that I imported, so I can then filter by those tags. I didn't do that here. So right now these samples are directly just within the mix, but we can see that my total updated. If I were running this in the background, it will run as a delegated job here. So rather than just taking up my screen in the foreground, this would have run in the background. We see an example here that I did in the past. That is not the only task that can run in the background. So if you're running any kind of compute task, such as importing data, like we saw earlier, if you're running a model evaluation, for example. So just real quick, I'm not going to run this, but just to kind of show you. You can delegate the execution, and it does the same thing. You can delegate it to a source of external compute. So there are many, many different compute tasks that do that sort of thing. Okay, so that is data repository integration. Again, the source of truth for any data in a data set that you're actually running operations on is going to be a cloud object store of some kind, or just an object store of some kind. And then FiftyOne also hooks into your data lens, into your data lake through a feature called Data Lens if you want to update your data sets or just query your data lake for certain samples. And this is just another summary of it as well. Cloud-backed media, again, is native integration to different cloud object stores. Data lens requires a specific operator that will define your connection to the data lake, what query parameters you support, as well as how samples are previewed. All right. And then again, this is just an example of the FiftyOne operator code that I showed earlier. You can find this exact same example in the data lens documentation. Okay, let's now move into the kind of user development workflows here. So the workflows I'm about to show, several of these can be done in the open source FiftyOne, except the fact that you're going to be wrangling with the SDK. It's a lot more manual in open source. But some of these, like model evaluation, we now have out of the box, what we call out of the box app native workflows in FiftyOne Enterprise. And then others like data quality only exist in FiftyOne Enterprise. And we'll show these here in a second. So just setting a little bit of context, like how can we troubleshoot broken models? So, right, you train a model, you validate it, you perform QA, you deploy it, it's not working in the field as you expected. So just a couple of examples. These are actually real life examples that we've encountered here with various clients and customers here at FiftyOne. One of them is a organization deployed a model that kept detecting potholes on the road. And as you can imagine, that causes some sudden behavior on the part of the self-driving system, right? It detects a pothole, it might swerve, it might brake all of a sudden. However, when actually verifying the environment, there were no potholes, except the model kept detecting them. Well, it turns out that storms came by and the shadows caused by debris of things like fallen trees, even if the trees weren't directly in the road, like a tree falling against a telephone line, for example, that caused shadows in the road that caused the model to interpret the conditions as potholes when they weren't. So what we can then do is we can perform tasks like, how can we fix this? Well, one thing we could do is we could perform tasks like embedding analysis and capture the effects of data that might be closest to this type of environment and see what its representation is. There might be issues with like poorly defined brightness, blurriness, contrast, or entropy that is not well distributed in our data set or has poor ground truth labels, such as our models aren't being properly trained as a result. We need to be able to identify those data samples, and it's not trivial to do so without a data curation platform that makes it easy. It's definitely difficult to do so if you're just managing raw files in a file system. Real quick, similar example, or slightly different example, but kind of similar line of thought. So a retail establishment, a grocery store, the AI cameras kept giving false reports that there was theft going on. So it kept reporting that, hey, these are suspicious people that are stealing goods from the store. That's because it was cold outside and everyone was coming into the store all bundled up. So it made them look like they were like shoving, goods and wares into their coats, when in reality, they were just wearing thick winter coats. Again, something we can start to look for in our data set to figure out, okay, is this something that we're correctly identifying to our model with the appropriate ground truth as expected behavior versus some kind of anomaly or some kind of true positive that the model really should be catching. So one of the key ways we can address this is through a workflow called data quality. So that comprises two components. One is the computation of various metrics like brightness, blurriness, distributions, aspect ratios. And then the second aspect is actually setting thresholds of this distribution to analyze it inside the FiftyOne platform to surface data that might be at different extremes of the distribution or might be within some kind of threshold. You might want to tag that data for further review to verify the labels. You might want to augment that data. So you might want to feed it into some kind of synthetic generator. You might want to augment the data with additional brightness, contrast, blurriness, occlusions, so that your models can have more representation of whatever class or distribution of data might be affecting it. All right. So what does this look like in practice? So I'm going to go back to the Berkeley Deep Drive data set here. I'm going to exit out of Data Lens. And here we see our data distribution as before. And I'm going to open a section called Data Quality, a panel called Data Quality, and put it side by side with the samples. And you'll notice that there are 6 categories of data: brightness, blurriness, aspect ratio, entropy, near duplicates, and exact duplicates. So each of these are computations that the FiftyOne brain tool can run, that you can run within the UI. So for example, if I can scan the data set for near duplicates, for example. I can run it either in the foreground, or like before, I can delegate it as a compute operation. Some of these other data quality metrics I already ran, for example, brightness and blurriness. So again, think about the types of conditions that self-driving cars would operate under. You'll want to make sure that those edge cases are well represented, such as blurriness caused by thick fog or rain on the windshield or heavy glare or just like poor conditions. So if I click into this blurriness section, we can see that we have this sort of like inverse exponential tail here, right? So extremely blurry conditions, there's a long tail. High contrast, so less blurry conditions are more at the beginning here. But what I can do is I can set a threshold where I might say, hey, let's look at maybe these sorts of conditions. Let's see what these look like. Yeah, so we can see some glare here, for example. And these are conditions that we might need some like further augmentation of, or might need some further examples of. There's a review mechanism. I can tag these. Oops, sorry. Oh, I don't know why actually. Normally I can tag these. I don't know why I can't here. Oops. That might be a permissions thing on my side with this data set. Okay, normally you can tag these. You can normally select the distribution and then add tags if they need further review. Let me go back to a different one, just real quick. Similar idea here. Going to brightness, slightly different distribution. Right on the right tail, we have the brightest samples. On the left, we have the darkest. Again, the idea here is you can start to get a sense of what your data distribution is. And again, the point of this histogram is to also get a sense of, is it correctly balanced according to what you would expect in real world conditions? In this case, you would expect a little bit more of a bell curve, right? Unless you want to have over-representation of edge cases to feed into your model. But in reality, or I guess, no, you would see more of an even distribution just because you have peak nighttime, peak darkness, and peak brightness, and then everything in between. It's the other one, brightness and blurriness, where you might have more of a long tail. All right. And then we have the other data quality metrics as well. I won't go through all of them here. Related to this, I just want to, this isn't directly the same thing as the data quality feature, but I also want to show you, let's see if I have the embeddings distribution here. Yeah, we also have our embeddings distribution, which again uses FiftyOne Brain for computation. Here we have a distribution. I can color by, say, label, and I can start to look for outliers, right? So if my model is, say, confusing like daytime and nighttime in conditions like dawn and dusk, or if there's streetlights or something, I can try to identify those distributions here in the embeddings. I can look for where data might be on an island. There's not really a great example here. This is a pretty continuous embeddings distribution. But if there was like an outlier here, I could lasso it and then filter by those samples that I've lassoed. Again, it's pretty common in other distributions where you might have like little islands of outliers, and you'll want to inspect further what those outliers represent. All right. Okay, so that's data quality. That is, let me check the Q&A here. Yeah, do you have, sorry, good question. Do you have capabilities that allow, I'll read this out loud, that allow users to augment their data set with Gen AI? I don't mean augment in the traditional sense. I mean create images to accommodate scenarios that we don't have real world techniques for, such as visual defect analysis and energy transmission towers. Okay, so native integration, not yet. So we don't have generative image augmentation as a native part of the FiftyOne platform quite yet. Let me real quick. I think you're talking about synthetic image generation, and let me know if you're not. Yes. I'm checking something real quick. Yeah, so I thought we might have had a plugin. Looks like we don't have a plugin for that quite yet. Yeah, let me do this. That's a great question. So we support any kind of arbitrary like importation of data, right? So like whatever tool you used to generate um, synthetic data and whatever and however you annotate them, they can be like easily imported into FiftyOne. What we don't have yet is like a one-click workflow for generate synthetic data directly within the platform based on a particular distribution. That's a great idea for a plugin though. So what I'll actually do is that's a good question. I'm going to kick back to our team because I know some of our team is probably thinking about that already, and I'll see what's in the plans. But yeah, great question. All right. But that becomes, kind of a logical, just to go on top of that, even if it's not done directly within the platform natively right now, that becomes kind of a very obvious next step, right? In the sense that, hey, you're identifying like poorly represented data, and the idea is I want to build off of that data to generate, more synthetic data. So one thing I didn't do is just if we're thinking about those workflows, if I go back to data quality here, right? If I establish a particular threshold, we'll say like brightness, right? Let's say I like have this like left tail of dark samples. This becomes what's called a dataset view, and I can save this view. I can save like this current representation as a dedicated view. What I can also do is I can share this specific view as well. I could also create a data version snapshot that I can then clone into its own data set. So basically the flexibility you have here is whatever tools you use next right now, say for like seeding for synthetic augmentation, you can easily grab these views here and use and kind of create their own data dedicated sets. Okay. All right. One second here. Do we have a dedicated NVIDIA Omniverse plugin with FiftyOne yet? We don't yet. So we are integrating heavily with Nvidia and partnering with them with their Omniverse platform. Here's my recommendation. My recommendation, I know the person to ask about that is if you're on our Discord, Dan Ural, who's one of our DevRel engineers, is intimately partnered with everything NVIDIA related. and he is the person to ask. So Dangural. I'm not sure if you've interacted with him yet, but he's definitely the person to ask. And even if we don't have like a dedicated plugin, he knows everything about what FiftyOne and Nvidia and how they interact in every single way. So if you're able to, so if you're involved in our Discord community at all, that's definitely, Dan is definitely the person to ask. All right. Let's talk about model eval. So data quality metrics, embeddings, they tell you how your data is distributed. Our model evaluation workflows evaluate model predictions against your data and allow you to compare models side by side. They give you the fundamental metrics, accuracy, recall, intersection over union, F1 score, any other custom metrics you might provide. Also, confusion matrices, where I've found this like the biggest time saver is being able to drill into confusion matrices and just very easily filter my data set based on things like class confusion. So here's a good example that I want to show here. I'm going to jump to a different data set for a moment. It is going to be a data set I'm going to over here called MVTech. This is a manufacturing anomaly detection data set. So there are at least a dozen different classifiers, so a dozen different types of manufactured goods represented in this data set. And the classifier is pretty binary. It's just defect or no defect. Um, Along with, we actually do have segmentation masks that can be layered over the defect as well, depending on the model. I guess because these ones there's no defect shown here. It's not showing the segmentation mask, but if I were to open up anomalies, which I will in a minute, we can see them. So let's say, so there's a couple ways that this goes. So when you run a model, what you can do is you can run what's called a model evaluation, in which FiftyOne will compute all of those metrics around the model predictions. So for example, we have this evaluate model, which can also be done in the SDK using FiftyOne Brain. And I kind of showed this earlier. You can update a predictions field. So in this data set, we've actually run already, we've applied two evaluations from two different models, a model called PatchCore and a model called PADEM. You can evaluate against the ground truth field. You can select the evaluation method. And then whatever, here it's just defect versus no defect. And then you can delegate execution. So again, we're not going to run the model evaluation here. That's already been done for us. And these labels here are represented. So the model predictions for both these models are represented here on the left-hand side. If I go to the model evaluation panel, which again, I'll put side by side, we have class-specific results for both models. So we can see kind of the different manufactured goods represented here for the PADEM model, as well as the PatchCore model. So let's look at an example here. So the one example is there's these like hazelnuts that have been that are part of this like manufactured set. I assume these are like decorative hazelnuts, that these aren't like real hazelnuts. They're manufactured, hazelnuts that'll go on the mantelpiece at, during the holidays or something like that. And this is just the prediction set for one model right now, this PADEM model. So we see core metrics like accuracy, precision, recall, F1 score against this class. True positives, false negatives, these are filterable. So if I click into, say, the 34 false positives in this class, for example, these are all instances in which the PADEM model incorrectly classified these as defective when they're actually not. So if I click into one of these, if we actually like interpret these, right, the defect status is normal. This is the ground truth. The PADEM model incorrectly classified this as an anomaly. The PatchCore model, on the other hand, correctly identified it as normal. So again, we have generated a data set view of false, in this case, false positives specifically for this PADA model against this hazelnut class. We can view other metric performances here, precision, recall, F1 score. We can see class performance, so precision per class again. So we can see that anomaly detections are not as great with this model. And then we see here a simple confusion matrix. Now here, this is just a 2x2 confusion matrix because we're not doing class comparison here. The only two quote unquote classifiers are normal versus anomaly, and they're like isolated per object. So in this example, it's not detecting between different objects. It's just detecting anomaly or no anomaly. And we can see in this model, right, we had 57 true positives. We had 13 false negatives where the model detected them as normal when they're not. And again, I can easily filter by that here. 397 correct identifications of normal, and then 34 false positives where they're actually normal, but the model thought they were defective. So for example, this here is the false negatives where these are defective, they're cracked, they're messed up, but the model thought they were okay. Okay, where the real power of this can come in is when you're comparing models. So let's say you can compare either different versions of the same model if you ran an evaluation for it, or you can compare between models. So here we have the patch core model for Hazelnut that we can compare side by side. I'm going to get rid of these here to reset my view. And then here we can see the metrics side by side. So we can see the summary metrics side by side. We can filter between false positive, true positive, false negatives, and so on. We can filter by metric performance. We can filter by class performance. We can see them side by side. We can filter by confusion matrices side by side. We can just at least get a snapshot view that, hey, it looks like the PADAM, the patch core model, was at least in the confusion matrix cells more performant around false positives and negatives versus PADAM. And we can see actually in this example that, yeah, so right, in this case, it's a false negative. I want to note real quick that this model eval framework is about to be updated. So right now we have the side-by-side views where, again, like any data set view, you can filter and slice and dice. You can set a review status. So if you're like a team reviewing model evaluations side by side, you can do so here. You can add evaluation notes. So you can just add any arbitrary markdown-based what is my qualitative notes around this evaluation comparison. We're about to release a new feature coming up called scenario analysis, which creates a slightly more regimented workflows in which you can like test different scenarios side by side and have a little bit more of like a task-based review framework that's a little more robust than just needs review and reviewed. It creates a little bit more of a project management framework around model evaluation, and that's coming down the pike. But again, right now, the real power here is being able to filter data side by side alongside the model eval metrics. All right. Okay, so that's data quality, model evaluation. Last few items I want to briefly make mention of are just like the collaboration aspects. So I'm just obviously one user. You'll notice that when I logged in to this environment, I was logging in under single sign-on. Ultimately, this is a multi-user environment, right? So if I go to settings and I'm an admin, we can see the list of all the users on this platform and their role, right? So if I go to role here, we have 4 built-in roles: admin, member, collaborator, guest, and we have the permissions that each person can have based on the role they're given. This cross maps to dataset access. So what I can do is I have users, and then I can organize users into groups of users. And then within a data set, like my MV Tech data set from earlier, if I go to the management pane, I can grant different users and groups specific access. So I might say I have a user called, let's see if my QA group is here. Yeah, I can add this QA group and they can have up to tag permission. So they have view and tag access. They don't have edit or full management access to the data set, and I can grant them access. Aside from just like the users and permissions side of things, there's also full data set versioning. So I'm going to go back here to my BDD data set. And anytime you make a change to the data set, you have the option to create a lineage-aware history of that data set. So if you've ever used Git, exact same concept. You create a chain of commits. The latest version of the data set is the head, but you can easily roll back or revert to a previous version if needed. That can be found in this history panel here. So we can see so far, I have like the current view, and then I have two previous snapshots. I have like an initial snapshot, and then I did like a Databricks import a month ago that added up 10 whole new samples, and I created another snapshot. And since then, I haven't created any others. What I can do is I can browse to a previous snapshot, and that opens up that view. So notice this previous snapshot has 625 samples, right? This is a previous view in the history of the data set. It shows me I'm like at that view. This is basically, again, like opening up a previous Git commit in source code. Within each view, you have the option to clone to a new data set. You can also roll back to the snapshot. This is like the danger zone of deleting a snapshot. I would not do this. This is like a Git force delete, but you do have that option. You can share this snapshot view with someone else. So again, very, very flexible here. Just be aware, if I roll back to this snapshot, which I'll do here, this is like a git revert in the sense that this becomes the new head. Or I'm sorry, this isn't even like a git revert. This is actually a destructive operation in the sense that this will become the new head of the data set, and you will lose any changes since then. So if you are reverting or restoring an old snapshot, any later snapshots after that will go away. So just be aware of that. So this snapshot name is after Databricks import. My latest version of the data set has 670 samples. Rolling back here, we'll make this the new head. This is now my rollback point. Let me just refresh the page so it updates. And then if I go back to history here, we can see this is the latest state. So I will say one thing that FiftyOne Enterprise does a little bit differently from some other platforms. So there's some SaaS-based platforms like RoboFlow, Encord. There's other platforms out there. 51 definitely like puts the tools in your hands around things like dataset versioning. It's easy. It's not hard, right? Again, it's just like with a couple clicks, you're creating dataset versions. It's not as inherently automated as some like SaaS-based workflows where like, hey, you do a dataset import and automatically it creates a new version. As someone who is a software developer by like trade, that I actually prefer the 51 way because it reminds me more of Git. Like, hey, it's up to the developer to like intelligently create versions of their data set and build it into their workflows. For me, that makes a lot more sense than like auto commits of new versions that you're not inherently like managing yourself. Um, because that might not be the branching model you want to do. One last thing, when it comes to branching models, there isn't an inherent way of like creating branches of versions within a single data set the way you would in like Git, right? The way you would do it here is you would take a snapshot and then you would, if you remember the snapshot dropdown, you can clone into a new data set. That's the kind of a way of replicating that branching model. Again, it's not the exact same thing as a branch with that shared lineage, but that is a way you can do it. All right. So that is dataset versioning. Again, dataset versioning, you can create new datasets and create that lineage-aware history. All right. All right, folks. That just about completes the content I wanted to go through, walking through 51 Enterprise. So thank you so much for your participation. I do want to provide just kind of a few areas of next steps before opening up for any kind of final Q&A. Again, my recommendation is kind of twofold. One, it's not on here, so look in the chat, is Discord. Our DevRel team is extremely active in Discord. Any questions you have at any time, like every day we do a sweep of Discord to make sure all questions are answered. So you will get feedback there if you want to be engaged in our Discord community. Try.51 is a good way to get some kind of to get your feet wet on the enterprise platform. Obviously, you have access to open source 51 as well. If I go into try.51, if it'll let me log in, you have these data sets called try, followed by a dataset name, for example, try BDD. Any dataset that has try, followed by a dataset name, has these kind of tutorial walkthroughs you can go through. The reason we built these was to try and accommodate the fact that this is a read-only environment. So there's some like automation in here where you can still see some workflows taking place with like embeddings, for example, but it's kind of done under the hood through this tutorial workflow, just for kind of security reasons. But there are ways where you can start to engage with the platform here in the try environment, and that's a good way to kind of get started and just start exploring around. And then obviously, if you want to book a demo, that usual kind of enterprise salesy pitch, you're welcome to go to click book a demo from the website, and then we'll be happy to kind of walk you through the product as well. That said, any final questions before we wrap things up for the day? Thank you so much for those who participated. All right. Well, once again, you will receive a follow-up email that contains this recording. Again, any follow-up questions, please, I highly encourage you to engage in our Discord community. We are all there and eager to help. And that said, thank you so much again for your participation. Thank you for attending this enterprise workshop, and have a great rest of your Wednesday.